thing. So once again, you double this, and then you divide it by 2. 3 pi over 4 is doubled 3 pi over 8, and then you divide it by 2. So now that we have that 3 pi over 4, this is going to be our x value. This over 2, all that tells us to do is to look at our identity sheet. Let's see if I have that. So that over 2 just tells us to look at the identity sheet. I gave you one today. You will have one you can use on your test. But we have tangent of something over 2, so we can use this one, or this one. Now, I didn't talk about it yesterday, but I'm going to talk about it today. If it's up to you, if you're just plugging numbers in, this one right here is generally speaking the one you want to use. And why you want to use that is, well, first of all, you have a fraction over a fraction, and then you have a giant square root. That's going to be hard to simplify. This one might be hard to simplify if you have 1 plus square root of 2 over 2, because then you have to multiply by a conjugate. This one will not have something you have to multiply by a conjugate by. This one is the easiest if you have a choice to use, because it's just 1 minus something over, and at most you'll have to multiply by a square root of 3 or a square root of 2 on top and bottom. So once again, I'll say it again because I don't see what I'm writing on there, but this is the one you want to use. So that is the one I'm going to use. It's 1 minus cosine over sine. So we're going to say this equals 1 minus cosine, and it's what that big red thing I circled is. So that's 3 pi over 4 all over sine of 3 pi over 4. Well, that's going to equal 1 minus, well, cosine of 3 pi over 4. Well, 3 pi over 4, that's one of our 4, so it's got to be square root of 2 over 2. And 3 pi over 4 is in quadrant 2, because it's 1 less, so it's going to be a negative square root of 2 over 2. And sine of 3 pi over 4 is square root of 2 over 2. In order to clear those fractions, I'm just going to multiply the top and bottom by 2. Because now when I distribute this, we're going to get rid of those fractions. So we're going to have 2, a negative times a negative is a positive. Square root of 2 over 2 times 2 is just square root of 2. All over, well, square root of 2 over 2 times 2 is square root of 2. Now we just have to get rid of that square root in the denominator. So we multiply the top and bottom by square root of 2. Making sure to distribute that square root of 2 to both things. That is going to equal 2 square root of 2 plus square root of 2 times square root of 2 is just 2 over 2. This 2 will go to both things. So really we have 2 square root of 2 over 2 plus 2 over 2, which on the test, I would say about 25% of us don't know how to do that. Make sure you know how to do that. You break it apart in 2 fractions. 2 square root of 2 over 2 plus 2 over 2, which is going to equal square root of 2 plus 1. So your correct answer was D, square root of 2 over 1. The hard part should be this. Because everything else is provided for you. This will be on the test. Once you have your x value, you just got to plug it in and then use your unit circle. All right, questions on the bell work? All right, then questions on the homework. Hope.
Number 21.
This is the wrong one. Number 21 is tangent of negative 5 pi. Is that the one?
Yeah.
Okay. Tangent of negative 5 pi over 12 equals plus or minus the square root of 1 minus cosine negative 5 pi over 6 over 1 plus cosine of negative 5 pi over 6. So for each equation, determine whether the positive or negative sign makes sense in the equation. Do not use your calculator. So we just have to decide if it's positive or negative. We just got to figure out what quadrant it's in. So you just have to figure out where negative 5 pi over 12, what quadrant it's in. So if you look at so this goes back to kind of the first stuff we learned. So I don't care about all the stuff that they told me over here. It's just kind of throw us off. So all of this is useless information. All it's asking for is tangent positive or negative at the angle negative 5 pi over 12? Now, in order to figure that out, I first made it positive, because a lot of times it's just easier to go in the positive direction. So I said I added 2 pi, which came out to 19 pi over 12, which is in quadrant 4. You could actually do 19 divided by 12 and see what number that is. It's close to 2-ish, so it'd be close to that. Or you can just change it to degrees if you want to. However you want to, you just got to figure out which quadrant it's in. That's all it's asking. Other questions? Yeah, Nicola.
11.
Specific question on 11? Okay, so we need to use the half angle identity for sine of 15 degrees, correct? So we're going to double that and then divide by 2. So I'm going to change sine of 15 degrees to being sine of 30 divided by 2. Correct? All right, so 30 divided by 2. Then you're just going to look at your formula sheet and say, okay, we're dealing with sine. So we're going to have 1 minus cosine of 30 degrees over 2. So once again, the flow of what I just did is I was given sine of 15 degrees. 15 degrees is not on my unit circle, so I use the half angle identity to change it to 30 degrees over 2, because they're both still equal. This is my x value. We are looking at our sheet here and saying, well, sine equals square root of 1 minus cosine. So we're going to say that equals plus or minus the square root of 1 minus cosine of 30 degrees all over 2. Well, the cosine of 30 degrees is square root of 3 over 2. First of all, we're in quadrant 1, so it's got to be positive, so I'm going to switch that right now. We'll have 1 minus square root of 3 over 2 over 2. I'm going to multiply top and bottom by 2 to get rid of that fraction, which is going to equal plus square root of 2 minus square root of 3 over 4, which reduces just to 2 minus square root of 3 over 2. All under, I'm sorry, it'd be the square root of 2 minus square root of 3 all over 2. Right. Good. Other questions? Mark? 7. So we have 4 pi over 3, and we are supposed to use the double angle identity for that one. So we have tangent of 4 pi over 3, but we do need to write it as tangent of 2 times something. So we're going to rewrite this as tangent of 2 times 4 pi over 6, which we can simplify that 4 pi over 6 to being tangent of 2 times 2 pi over 3. And this is going to be the x value you plug into your formula.
Oh, I did 4 pi over 6.
Oh, okay. Yeah. 4 pi over 6 will still work. You just have to reduce it so you know where it is on the unit circle. Because 4 pi over 6 almost doesn't look like it's on the unit circle, but if you reduce it, then it is. Is that far enough, you think?
Yeah.
Okay.
I have another question.
Okay.
31. I just, like, I was confused because it had, like, pi over 8 minus pi over 2 on the other one.
Mm-hmm.
1 and then pi over 2 minus pi over 8 on the other. So
Mm-hmm.
1 negative and 1 positive.
Mm-hmm.
I was wondering what to do with that.
So on the answer key, this is one that I really worked out. I skipped on a bunch of them, but this one I definitely worked out because you need to know how to do this. First of all, we don't have an identity that we have. I guess we could do the subtraction, but we're in double and half angle. So I'm going to put these together by making a common denominator, which you said comes out to a negative and positive one. Yoink. That's the odd, even identity that you can pull that negative out. Mark, if you really wanted, you could have made this one -2 to match it. Because cosine of -3 pi over 8 is the same thing as cosine of +3 pi over 8. I like to remove negatives rather than adding them. But you could have. Other questions? Guys, for those of us that didn't do this homework, make sure you get this done. It doesn't get easier. And if you don't know these basics, today is going to be rough for you. It's going to be rough, and it's going to get rough. All right, I'm going to tell you right now, this stuff isn't hard, but it's just hard to comprehend what I'm doing at first. Like the actual math behind it isn't hard. It's just hard conceptualizing why I'm doing it to get the answer that I am. So we're going to one more of these problems where we're given some kind of trig value. In this case, it's sine of 2 alpha equals -8 over 17. And we have twice an angle is somewhere between 180 and 270. So 2 times an angle is going to be in quadrant 3. We're going to put a pin in that quadrant stuff for just right now. We need to find sine alpha and cosine alpha. I don't have any 2's in front of there. Right now I have a 2 in front of here. Whenever we're doing a problem that we're given a double angle, anytime we're given a double angle, we automatically have to find cosine 2 alpha. Automatically, no matter what I'm asking for, you always have to find cosine 2 alpha first. And the reason for that is you could think of cosine 2 alpha as the key to all of the other, as the key to all of the other identities. Because cosine 2 alpha can be written as cosine squared alpha, which gets rid of that 2 on the inside. And it can also be rewritten as sine squared alpha, or x. So cosine 2 of x can get us to our cosine value and our sine value. Your sine 2x muddles everything up by putting 2 in there. I can't actually solve for one of these unless I know 3 different things. I would need to know this and the cosine x in order to solve for sine x. But if you know cosine 2x, you can solve for cosine x and sine x. So anytime we're dealing with a double angle, you have to find cosine 2 alpha first. You have to find cosine 2 alpha first. And it's kind of odd how we do it. We are going to go back to the fact that, remember we had sine squared plus cosine squared equals 1. And we could shortcut that to being cosine squared. Actually, did I shortcut it in the notes? Yeah, I just don't have enough room. But this comes from our cosine squared plus sine squared equals 1. We're going to say cosine x equals the square root of 1 minus sine squared x. That just comes from cosine squared plus sine squared equals 1. This isn't a new formula. We've seen this. You can still use cosine squared plus sine squared equals 1 if you want to, plugging stuff in. What we are going to do here is we are going to let x equal 2 alpha. Because x and 2 alpha are just placeholders. So I'm going to replace both those x's with 2 alpha. Which should mean cosine of 2 alpha equals the square root of 1 minus sine squared 2 alpha. And now we know sine squared 2 alpha actually equals negative 8 over 17. So we're going to replace that in there. So we're going to have cosine 2 alpha equals the square root of 1 minus a negative 8 over 17. All right, negative 8 over 17 squared. Here's where you'd probably take out your handy dandy calculator. And if you do the math correctly, you're going to come up with this is going to equal the square root I guess we'll just do the whole thing. Plus or minus the square root. You're going to have 64 over 289, which means you're going to change your 1 to 289 divided by 289. Which, continuing to simplify, should be equal to plus or minus the square root of 225. That's too many. Over 289. Which means the cosine of 2 alpha equals plus or minus, I'm going to leave that for just a second, 15 over 17. Now we just have to decide if it's positive or negative. So now we go back up here and it says cosine of 2 alpha. So I'm looking at this double angle. That double angle is in quadrant 3. So we just ask ourselves, is cosine positive or negative in quadrant 3? You do all students take tangents positive, everything else is negative. So that means cosine must be a negative 15 over 17 because we're in quadrant 3. Unfortunately, we didn't actually solve for anything that I wanted to yet because I need sine alpha and cosine alpha. This is just our key. It's our key to get to those two. So we are now going to use that value to solve for the rest. So the first thing we're going to solve for is cosine alpha down below. So we'll move down that next box. We're going to solve for cosine alpha. So then we're going to look at our identity sheet and say, well, cosine 2x equals 2 cosine squared x minus 1. Well, I can use that one to solve for just plain cosine of alpha. Because as I write this out, we can rewrite this as cosine 2 alpha equals 2 times cosine squared alpha, right from here, minus 1. But I know cosine 2 alpha. That's what I just found right before. I said cosine 2 alpha is negative 15 over 17. So we're going to replace that with negative 15 over 17 equals 2 times cosine squared alpha minus 1. Well, the first thing we're going to do is we're going to add 1 to both sides. Picture that 1 is 17 over 17, so we're really adding 17 over 17 to both sides. So we're going to have 17 over 17 minus 15 over 17 is going to equal 2 cosine squared alpha. 17 minus 15 is just 2 over 17 equals 2 times cosine squared 1 alpha. The next thing we're going to do is we're going to divide both sides by 2. Think about it this way. It makes it easier with fractions. Rather than divide both sides by 2, just multiply both sides by 1/2. Bless you. Because people have a lot easier time multiplying than dividing fractions. So just think about it as multiplying 1/2 on both sides. So we're going to have, multiplying by 2, we're going to have 2 over 34. equals cosine squared alpha. Now we're going to take the square root of both sides, and we're going to end up with cosine alpha equals plus or minus the square root of, well, what's 2? I'm going to simplify that real quick. So that's actually 1 over 17. So we're going to have the square root of 1 over 17. Well, that's really just square root of 1 over square root of 17. So you multiply the top and bottom by square root of 17. So your cosine alpha is going to equal square root of 17 over 17. Now we have to decide if it's positive or negative. Mark.
Why don't we like plug in for instead of plugging it in like 2a,
Mm-hmm.
why don't we plug in cosine squared a for like 225 over 289? Isn't that the same as cosine squared a?
Say that again with 220. What was that?
Isn't 225 over 289 the same as cosine squared a? So why don't we?
It is not. That would be cosine squared 2 alpha if I'd square both of these.
Oh.
Be clear here. This is cosine 2 alpha. This is cosine 2 alpha, so that can only go in places that have 2 alpha signified. Because if you'd replace it here, that would actually make this 2 times 2 alpha because you're replacing that alpha with 2 alpha. You kind of see? That's where it gets a little conceptually hard. You have to keep your 2 alphas and your alphas separated. You're dealing with 2 different angles. All right, now we have to decide if we're doing a positive or negative. Here's where we have to do a little extra work. My double angle is in quadrant 3. So if I'm ever dealing with 2 alpha, I'm in quadrant 3. When I'm dealing with alpha, I have to adjust this formula just a little bit. I have to have alpha in between the middle. So that means I'm going to divide everything by 2. So if I divide everything by 2, we're going to have 90 degrees is less than alpha is less than 135. That is in quadrant 2. So anytime I'm dealing with alpha, we're going to be in quadrant 2. Yeah, Emma.
So you just divided it by all of them by 2?
I divide everything by 2 so I can know where alpha lies.
Because the next one is alpha.
Because the next one's alpha. Yep. I need to know where alpha is actually turning to. So we're multiplying an angle by 2, right? So say I have 100 degrees. Multiply it by 2, I'm looking at 200 degrees. At the 200 degree angle, I'm in one quadrant. At the 100 degree, I'm in a different quadrant. All right, so we are in quadrant 2, which means that our cosine is actually negative in quadrant 2. The good news is, as soon as I get cosine or sine, we can just go back to sine squared plus cosine squared equals 1 to get our sine value. So that's what we're going to do to get our sine value. We're going to say, okay, I can go back to my trusty sine squared alpha plus cosine squared alpha equals 1. I'm actually solving for sine, so we're going to have sine alpha equals the square root plus or minus 1 minus cosine squared alpha. Bless you. So now we're going to plug in that cosine alpha real quick. So we'll have 1 minus, and we came up with, you can use either one of the, you can use 1 over square root of 17, or you can use the square root of 17 over 17. I don't care which one you pick. I'm just going to pick the negative square root of 17 over 17 to hopefully not lose anyone. That's going to equal plus or minus the square root, and that would be our 289 again, right? I retract my statement. That's going to get really complicated. I'm going to replace this one. I am going to use the version where it's negative 1 over square root of 17. There's no reason of doing it hard because you can. So just remember I got that from here. I just didn't simplify it. Our cosine alpha equals 1 over square root of 17, unsimplified. So that's what I'm going to put in that box. Well, that's going to be 17 over 17 minus square root of 1 is still 1. Square root of 17 squared is going to be 17. Carry that up. We're going to have plus or minus. The square root of 17 minus 1 is 16 over 17, which is going to equal plus or minus, square root of 16 is just 4 over square root of 17. So our sine of alpha is going to equal plus or minus, I'm going to hold on to that, 4 square root of 17 over 17. What quadrant is alpha in? Andrew. It's in the second quadrant. Is sign positive or negative in the second quadrant? Positive. So it's going to be positive because we're in quadrant 2. Guys, this stuff can be pretty hard if you don't practice it. So if you're one of those people that just use the answer key, you're going to get stuck on this on the test. You have to practice these and know the kind of order to doing them.